Well, just like when we solved quadratic equations that we've seen before, we couldn't always do that using factoring. Instead, we had to use the quadratic formula. So we're going to apply the quadratic formula to solve these trig equations. Let's start by identifying the a, b, and c out of my trig equation so I can use the formula. So a, in this case, is going to be 3. B is equal to -1, and C is also equal to -1. Now let's use the quadratic formula. It says that if I take the sine of x, that's equal to negative of b, which is a -1, plus or minus the square root of b squared minus 4 times a times c divided by 2a. So we're going to plug that whole thing into the calculator and we get two answers. The first answer that I get is going to be a plus, and then we do it again for a minus. So when I plug that into the calculator, I get that sine x is equal to 0.7676 for the first angle, and I get sine x is equal to -0.4342. So obviously I'm going to have to plug these into my calculator to find out what angle we're talking about. Since we're doing that, let's just address what's going on, or what quadrants we might have going on here. So in this particular solution, when I take the sine of some angle, I get back a positive value. So I must be talking about an angle for x that is in both quadrant 1 and 2. So I'm going to get two solutions here. And on this one, when I take the sine of some angle, I get a negative value. So these angles have to be occurring in quadrants 3 and 4. So we're going to keep that in mind as we let the calculator do its magic. So when I put the inverse sine into the calculator, remember that we're going to enter it into the calculator so that it looks like inverse sine of 0.7676 and inverse sine of -0.4342. Just looking at this first equation over here, the one where I get angles in quadrants 1 and 2. Remember, when I take the inverse sine on the calculator, I had to restrict my domain, and the domain of inverse sine is only for values here in quadrants 1 and 4. So when I take the inverse sine on the calculator, it's only going to give me one of my two solutions that are positive. So it only gives me one angle, and I need to find the other one. So I'm going to draw a picture of what it gave me back. When I take the inverse sine of 0.7676, it gives me 0.8751, and that is this angle right here. This is 0.8751. I also need that same angle that would occur over in quadrant 2. So that is this value over here. So this is quadrant 1. And quadrant 2 is going to be then pi, because I've got to go all the way to pi, and then I'm going to subtract off this little pi shape, this little bit right here. So I'm going to say that that's going to be pi minus 0.8751. And that gives me 2.2665. So I have my two angles that are occurring in quadrants 1 and 2. And we're going to do the same thing over here, only we're applying to quadrants 3 and 4. So it usually helps if I draw a picture. So again, when I take the inverse sine on my calculator, it gives me back these angles in quadrants 1 and 4. I know when that I'm looking for angles in quadrants 3 and 4 though. So when I take the inverse sine, the calculator gives me back -0.4492. Now where is that? -0.4492 is this negative angle. But I need angles in quadrant 3, which would be over here, so I need this angle, and I need the angle in quadrant 4, which is coterminal, right? But it has to come all the way around and be positive, in other words. Now, how do I get those angles? How do I get the angle in quadrant 3? That comes from halfway around, which is pi, plus that little pi shape, 0.4492, and then quadrant 4 is going to be 2 pi minus that little 0.44. So 2 pi minus 0.4492. On the calculator, these values come back to be 3.5908 as well as 5.3840, I believe. So I have my 4 angles. Let's put a circle around them. I've got 2 angles here for quadrants 3 and 4. I've got 2 angles here for quadrants 1 and 2. And these are the angles that I would need to just be on the interval between 0 and 2 pi. Now, let's write that solution. So here are the solutions that I found on the interval between 0 and 2 pi. What if, however, I asked you for all possible solutions? When I talk about all possible solutions, I have to adjust my solution set. So if I let's start with this. Let me erase this over here. If I had this angle here, which I know is 0.08751, and I went around the circle, that's 2 pi, I would get another angle coterminal with this. So that would be 0.8751 plus 2 pi. And if I went around the circle 5 times, that would be 0.8751 plus 2 pi times 5, right? Because I went around 5 times. So we put an N on there to indicate the number of times I went around the circle, or how many revolutions did I go around. And that brings me back to that same exact angle, because remember, I have multiple angles for solutions on a circle, because I can keep going around and round. So for each of these 4 solutions that are just between 0 and 2 pi, I can represent all possible solutions by adding 2 pi n to them. So here I have all possible solutions for this equation, not just the single revolution, but all solutions. And that's how you write all of them.